Okay, so teams, good evening all. A, a warm welcome to the BAJA SI India webinar series 2026. Today, we are excited to bring you an extensive technical session on simulating an electric BAJA vehicle with Matlab and Simulink. This session is designed to help you dive deep into the world of electric vehicles, modeling and simulation using industry standard tools from MathWorks. It is my pleasure to introduce Dr. Veer, a distinguished mechatronics engineer and education leader dedicated to fostering industry-ready skills in students through model-based design. Dr. Veer holds PhD in Dynamics and Controls and currently leads the Global Education Program team at MathWorks India. Here, his Dynamics team empowers students and educators worldwide to explore innovation through MATLAB and Simulink. Through his leadership, dedication, and vision, Dr. Veer continues to drive transformation in engineering, education, and skill development across India and beyond. So, join us welcoming me, Dr. Veer, for a introductory session. Uh,
Yeah.
uh, yeah,
Uh,
sir. Over to
yeah,
you.
thank you. Yeah, thank you, Rhythm. Thank you for the introduction. And once again, really thankful for the Baha organizers to giving us the opportunity. So my name is Veer Alakshant, and I work at MathWorks, and I manage the student programs team in India, and also supporting multiple automotive competitions, including the Formula Student and the Baha competitions. So I think we have been doing this webinar since such webinars since many years for the Baha students. So many a times, most of the times, new people join. So what we are going to do today is basically the whole goal is basically to show how you can build electric Baha vehicle model or simulate electric Baha vehicle model in Simscape. A lot of you, a lot of teams, we know that they have been already using the tool, all the even the different models that we have published. The goal basically for us today is that I think most of you know that we have launched new electric vehicle Baha challenge in collaboration with Baha, specifically only for the Baha students. So the workflow or the content that we are going to show today will help you participate in that challenge. Again, that challenge is not compulsory. It's your choice. If you want to participate, you can participate in the challenge. It's not mandatory for every team to participate. The goal is to basically give you a learning experience with modeling tool, and also if you win, you also get some good rewards as well. Okay. So with this, we'll get started. So what are we going to do today is basically we need to sort of like the way how the industry works, especially the electric vehicle. The powertrain is one of the important section of that electric vehicle. So we'll deep dive into some cell characterization. Okay, there are certain limitations with the Baha team which we are aware of that not all the teams are having the cell data, but still, I mean, if you want to try the whole workflow, we will be adding those data in the GitHub repository. So if you want, you can try the same data. You can also use that in the challenge. Okay. And meanwhile, I'll keep on, since I'm just today using one screen, I'll keep on just hopping around in the chat just to see that, okay, if there are any questions. Okay. So there's a question, do we simulate today? No, we are not going to simulate today. This is a almost 2 hour session. It will be mostly, I'll be presenting the content along with opening MATLAB and different models because we don't have that much time to do exactly the hands-on thing. But yes, all the models, all the files are available. You can try it by your own. Okay, and if there's some data, which will be, I think, mostly by tomorrow morning, we'll be uploading on the GitHub repository. Okay. So we'll talk about the cell characterization. I'll show you the method how to characterize the cell, which is an important aspect when you are building an electric vehicle, because any electric vehicle you build, uh, if the data is not correct. I mean, it doesn't make sense. Of course, there are, I mean, whichever tool you use, many times all the data is not there. So in that case, at least you should understand the assumption that is the model is based on. Okay. Then the battery pack design, and then we'll go into SOC estimation, and then we'll head to the electric powertrain design. So this is how we'll proceed. Okay. So in terms of agenda, again, just going through all these topics, and then finally we'll land up into giving an overview, or if you have any questions regarding the electric powertrain simulation challenge 2026, feel free to ask today. So with this, specifically, I would say that we are going to use Simscape. Before I get started, I just want to understand, you can just, I don't know, like if you all have the access to chat, at least say yes or no in this. Okay. Um, I mean, the question is basically, are you aware of basic MATLAB and Simulink? You can just type yes or no in the chat. I believe I see people are writing, I mean, they are chatting. Okay. Yeah. Okay, fine. Okay, so I'm getting some mixed response to it. Okay. Okay, so most of them, yes. Okay, but still I'll give an overview of MATLAB and Simulink. Okay, just a quick overview, and then we'll deep dive into the physical modeling. And I also saw one question, which was like, what is the objective of the presentation? The objective of the presentation is to help students of BAHA to build electric vehicle models using MATLAB and Simulink. Okay, specifically using physical modeling approach. Okay, so before I move into Simscape, let me just quickly open MATLAB, since I saw some no in terms of, I would say, whether you are using MATLAB and Simulink or not. So in that case, let me just switch to MATLAB quickly. Okay. Okay. So this is the MATLAB window. Okay. And students, I mean, or the teams, those who are not having the access to MATLAB, they can just type on Google, they can just type BAHA MathWorks. Okay, so you'll get a dedicated page by MathWorks for BAHA SE India. Okay, and then from there you can request software. Okay, and this is software. It is specifically only for the BAHA students. If you are from any other competition, you can reach out to me. I'll share the email ID as well. And then further, there's no limitation on the number of students in the team. So if you have like 15 team members, all the 15 team members can use the license. Okay. And we have also not put any major limitation on the toolboxes. Most of the toolboxes, those are provided to the industry. Those are also available in the license. Okay. So yeah, so this is the MATLAB window. This is how it looks like. You have, and the version that I'm using is the 2025B version. Okay, so you might see some difference because there's a major change in the view of MATLAB since 25A. Okay, so this is how it looks like. So this is your current folder, basically the folder which contains all the supported files or the files on which you'll be working on. And then you have a workspace over here, and this is the command window. Now, if you see over here, I mean, if you want to define any variable, for example, a is equal to 2, so you can see over here, it comes in the workspace. Okay, so basically all the variables are visible in the workspace. Similarly, b is equal to 3. So similarly, you can perform different applications, a into b, sorry, a into b, and then you just get 6 over here. Okay, so you can see all these variables are in the workspace. Now, one important update is that we have also launched in 25B called Copilot Chat, okay, which is basically a generative AI based MATLAB Copilot. Okay, so you can give the prompt, okay, and you can see the results. It will provide the MATLAB code to you. Okay, and it can also teach you, I mean, help you learn or kind of debug things. If you see any error, it can point you to that, and it can help you to address those. Okay, So this is called MATLAB Copilot. So I'll close this. This is not required currently. Okay, so this is how it is. You can do perform different applications, but in the command window, you can't keep on writing or repeating the code. So for that's why we have something called as live script. Okay, so in live script, you can see you can write code over here, like a is equal to, you can use certain built-in functions like and yeah, as you can see that MATLAB also has multiple features of, like, for example, if you want to use any built-in function, so it will give you some suggestion. You can see round, ran. Okay, like if you want to create a random matrix of 4 comma 4, you can just click on this and it will create, and you can visualize that random matrix in this. Similarly, you can over here, you can insert text, you can add images, you can add tables. Okay, it is quite interactive with, which will give you kind of a live feeling of preparing a documentation. And further, this document can be also converted into different formats like HTML or PDF. Okay, now in short, what are we doing with MATLAB? MATLAB is basically for it's a programming language for engineers and scientists for different applications for modeling, data analysis, AI. All these things can be done. Okay. Now, before I move to the Simscape part, let me get into Simulink. Okay. Now, if I go into Simulink, I'll just type Simulink to open Simulink, or there are other ways as well. And from the tool strip, you can click on Simulink and you can also get, start at Simulink. So when you start Simulink, meanwhile it is opening, as you see. Okay, fine. So yeah, once you open this blank model, you will have a canvas model over here. And then this canvas model will give you space, okay, a canvas, a free space, and then library will be coming over here. Okay, so in the library, what will happen is that you will see multiple blocks, okay, which can help you model a system. For example, if you have a mathematical equation that can be converted into a model. Okay, for example, I just want to bring a constant over here. Okay, and then if you want to add, you can just bring some add over here. Okay, similarly, one constant, and then further, you can just put a scope. Okay, and then you can just click, or better, you can even, if you don't want, because these are just constant, okay, it is not varying with time. So you can just, okay, and you can see it's two. Okay, similarly, if you want to visualize something or plot something like a sine wave or something, these all can be also done. So basically, what is Simulink? Simulink is a graphical modeling environment which is having blocks which are present in the library that can help you model dynamic systems. So systems which varies with time, like your BAHA vehicle or your aircraft or your aerospace systems or robotics. Okay. Now, it was just an overview. I mean, since I saw some of the people, they have written, they have not used MATLAB and Simulink. So that's why I just gave a quick overview of MATLAB and Simulink. Okay. So since you are new, so those who are new, for that, for them, you can just go into MATLAB on-ramp tutorial. Similarly, we have different self-paced, let me just open a better one. Okay. So when you go to self-paced courses, okay. So all these courses that you see over here, MATLAB on-ramp, Simulink on-ramp, these are free for everyone. And then for the BAHA students, these trainings are also free, like Simulink fundamentals, which go into detail. All the on-ramps are already free for everyone. They just need to log in with their MathWorks account. And otherwise, if you see some of the other trainings, okay, like which comes into OTS, that is the online training suite, these are all available for BAHA students only. Okay, so they can also, if they want to have, they want to build some proficiency in MATLAB, so after doing on-ramp, they can go to this learning path and they can learn more. Okay. So, or one is that, like, they will the Baja students or the universities or the institutes or schools, those who are having the campus-wide license, for them also, this OTS is available for them to learn. Okay, now the interesting part comes over here, and we'll get back to our main thing. Before that, let's see the chat if there is any question. Okay. Yeah. And let me just see if there's any questions. Okay, there are some questions, but I think those are relevant when I go further. Okay, perfect. So here we are. Okay, so what is Simscape? Now with Simulink, what was happening? Like you need an equation. You need a equation. Using that, you will model a system. Now, Simscape is basically meant for physical modeling. When we say physical modeling, what do you mean by basically physical modeling? Can anyone say in the chat what do you mean by physical modeling? Anything like I mean, I'm just trying to be interactive. If you have any understanding, not of Simscape but physical modeling, what do you mean by physical modeling?
Oh. So you want me to open a mic for everyone, or like?
Then what we can do is that we can open the mic maybe I think once the session is, I mean, towards closure during the Q&A
Mhm.
part. I think that will be better. Otherwise, it will be it will be difficult to kind
Yeah.
of manage everything. Yeah. Okay, so
Okay.
yeah.
Yeah.
Yeah, so I can see application of thermal equation of cell in Simulink. Okay, fine. Practically, yeah. So basically, I mean, practically is a good word, actually. I agree with that. So basically, something, it is made of physical systems. Okay, something, systems which you can feel, you can sense. For example, if you take a spring mass damper system, okay, spring is a physical system. Okay, similarly, you have damper. Similarly, in the electrical system, let's take an example of a DC motor. Okay, so if you want to build a DC motor, this is how it looks like. Okay, so it has different physical like elements like resistor, inductor, electromagnetic converter, and inertia. Now, the advantage of this is that you don't need to uh, derive the equations for this. So what happens is here the only thing that you need is understanding of your physical system. For example, if you know that you have to build a spring mass damper system, so you need to understand what are the different elements in that physical system. Like, okay, like spring damper, then there will be a mechanical reference, there will be a mass. Okay, so if you have understanding of that and the physical layout of it, for example, this is something that you can also draw with pen and paper, this structure. Then in the software, that what we do is we replicate that physical layout into a simulation model. Okay, so for example, okay, let's see. I'll give you an example of a cell. Okay, so before that, let me just go over here and bring the library. Okay, and then I'll come to the cell part. Okay, I'll delete this, which I was talking about, and then you have sort of Simscape. Okay, so what we did, where do you find it? In the library browser, you have Simscape, as you can see over here. Okay, as you can see over here, Simscape is there. Okay, then you have different, under that, you have different sections, different toolboxes, battery, driveline, electrical, fluids, foundation library, multi-body, and different utilities are also there. Now, I was telling that for a cell, if you have to model a cell, and that will be our first topic, okay, which we'll be discussing, okay, in detail, is that if you have to model a cell, basically a ECM model, a equivalent circuit model, okay, forget about, there are different time constants, there are different RC pairs, okay, it depends upon to what level you want to. You can, if you are modeling a cell, okay, basically your system layout or electrical physical layout will be open circuit voltage. You'll be have one time constant or second time, the second time constant or RC pair, and then one R naught will be there. Okay. Now we'll go in detail what is the significance of all these elements. But just imagine that this is the image with some pen and paper. Now, this is the physical layout that you have to build over here. Now, if you need to build that physical layout, what you need to do? Okay. So what we do over here is that we go to the foundation library. Okay. And in this one, we go to electrical elements. Okay. And in the electrical elements, you can see over here, we have a resistor. Okay. Which let's take, which this is the R naught. Okay. Or even, for example, like if I just type like, uh, circuit of a cell. Okay. So in the, sorry, of a cell, there's a type. You see over here that this is what, for example, this is the thing that you want to just sort of build that or replicate that in your model. Okay. So it has R naught, R1, C1, and an open circuit voltage. So let's see what do we do over here. Okay. So what we do here is, let's see that, let's say that this is the R naught. Okay. Similarly, we'll just copy and paste over here. This we'll keep it as R1, and then we'll bring one. Let's keep over here, and then we'll bring one, drag one capacitor. Let's name it as C1. Okay. And then what other element do we need? We need a voltage source. Okay. Voltage source. And then let me just keep on making sure that these are on. Auto name. Yes. Okay. What else do we need in terms of physical system? Anyone else? Like, do you want to add anything? So we want to just draw a cell model. Okay, electric uh, circuit of the cell model. What other elements do you think that we need over here? Can you just type it in the chat? Oh, okay, yeah. So yeah, currently motor we won't add. Yeah, voltage sensor is one, signal processing of sensors. Yeah. So let's do one thing. What we'll do is over here, we'll bring one voltage sensor as we saw in the chat. Okay. And then control I. And then what we are going to do, we are just going to replicate what you have in the what you have in the rough layout. Okay, or the electrical circuit. So this is one. Okay. And we'll just close this. And then what else? The one important thing that we are missing is basically a electrical reference. Okay. So this is one, even like this is something again, when we draw the electrical circuit, this is required. Okay. So over here, and then again, all these blocks have description. And if you want to understand like how it is being modeled, or some of the blocks are also open, you can also click on the source code and understand how it is built. Okay, but it is sort of gives you an understanding that what it is. Like for example, for electrical reference, it is an electrical reference port. A model must contain at least one electrical reference port, which is the electrical ground. Okay. So we all know by basics, okay, for electrical system, we need a ground. Okay. So that's why we are using it over here. And then further, what we do, like we'll add a voltage sensor over here, connected. And then there are few other important, I would say, other important blocks, which are important by default, should be there when you're doing a physical modeling. Okay. So that block is called solver configuration. Now, why do we use this? I mean, we can take a whole session on this, but just sort of to understand is that basically what is happening, it is solving some set of differential algebraic equations. Okay. So when you model in Simulink using Simulink blocks, like earlier previously the blocks that we showed, which were black in black and white, those are Simulink blocks. In those cases, you don't need to add that, okay, because already the global solver is taking care of that, which can be found in the model settings. Okay, so you have solver settings, which solver you are using. Okay. Then when it comes to Simscape, okay, Simscape will solve for the physical system signals. Okay, that's what it is doing. And then you can, I mean, shouldn't say that, but you can just imagine this as a local solver and a global solver. So this is a local solver. Okay. Now further, you can see over here in this block, okay, there is a black signal over here. Okay. Now what this black port over here, so this block basically is a signal. Okay. Now we want to sense the voltage. Okay. So in that case, what do is, give me a second. What do we do is that we need to convert this physical signal into a Simulink signal. So we do this PS Simulink converter. I just connected over here and we just put to scope. Okay, and then we can run the simulation. This is how your whole circuit is built. Now, if I just compare with the image that we are talking about, you can see that we are just basically mimicking your layout, the electrical layout that you have drawn with your pen and paper or based on your understanding. This is what we are mimicking over here. Okay, perfect. Okay, regarding this, you have any questions? Okay, I can just take a pause a little bit and see if there are any questions. Yeah, fine. I can see, I think I can based on comment it. Also, I can see that people are having some even like I think some already good experience with the tool. So good to know that. Yeah. Okay. So let me just go to that. And sorry, this one is a chat. Okay, no more questions. So now look over here. What we did was, now this is just like focus on this, like what we are going to talk about. Now we'll slowly move to the cell characterization. So what is happening over here is that we have replicated a cell model. Okay. Now there are other options as well. So what happens is that if you want to not go to the foundation blocks. So these are what foundation blocks. You're building from foundation based on your understanding of the system. Now this whole, what is it representing? It is basically representing a cell model. Okay. So if you don't want this, another option is that you can directly use a block from the electrical library, okay, which is called Simscape electrical. Okay. So you can go over here and you can see, one second. Yeah, you can go over here, you can go and then you can see different components, electromechanical, additional components, sources, all these things are there. Okay, like in here, you can see over here that you already have a cell. Okay, so you already have a cell over here. So basically, what you can say is that this whole thing can be directly used. Uh, rather than going with this approach, okay, you can also, if you want, you can directly bring a block. So this block already takes care of this modeling part. So basically, you are shrinking the whole model into this. Okay. So further, you can see what are the parameters, those are required, this and that, all these values are in there. Okay. Now, if you have to sort of like model a cell again, here what will happen is that we'll just put it over here and then we'll have signal, and then further you can bring a current source right here. Okay. You can have a current source over here. Yeah. You can have current source over here. Similarly, you have voltage source over here, and then you can make the proper connections so that this model, okay, shrinks to this model with a already built-in battery, which is table based. Okay. Now I'll remove all these. Okay. Now I'll tell you what is the challenge actually, because when you use any software, right? Okay. The important thing is how do you parameterize or how do you put the values of certain parameters. Okay. Now let me just put that over here. Okay. Now see over here that when I double click, so this requires so much of data. You see over here, this requires so much of data. It requires all this data. Okay, it requires state of charge. It requires your V naught. It requires your temperature if you have temperature. Not necessarily if you have a constant temperature, that also works. Then you further, when you go to the dynamics part, now see over here when we are understanding the cell, so you have one time constant. So it is asking for R1 and tau 1. Tau 1 is basically time constant, which is R1 into C1. Okay, so resistance into capacitance. So now the basically the challenge when you're using these modeling tools or any modeling tools is basically how do you how do you find these parameters? Okay, so this is what we are going to answer now. So that is important. Now let's go back to the slide. Okay, so I hope until now you have got an understanding of how mm, okay, how you sort of like model systems in Simscape. Okay. Okay, fine. So with this, I'll go into some details of the cell characterization. Okay, so we already saw that how a equivalent circuit model of a cell looks like. Okay, so it can have different number of RC pairs. Okay, this is like having two RC pairs or two time constants, we can say. Uh, Now, as I said, the challenge is basically finding the parameters. Okay. So the most important thing that you need to sort of parameterize a cell is basically having the data from the HPPC test. Okay. So how do we, how does the data look like basically? So based on the charge and the discharge. Okay. You can see the current plot over here, the discharge and the charge. You have certain voltage response. Okay. So when you do some HPPC test, what happens is for certain charge and discharge for a period of time. Okay, so it is for a longer time. For a period of time, you get certain response for the voltage. So to be precise, okay, for example, let me open one data sheet. Okay, so I hope I have. Yeah, this is one. Like I would say, this is more synthetic data that we have. Okay. So you can see over here, this is one of the HPPC tests done for the cell at certain room temperature. You can see this is time, current, and voltage. Okay, so this is what you get. This data is basically required because if you want to exactly model the battery. There are other approaches also. For example, like if you don't have the data, so that for that also, like you can simply use a simple battery block, okay, which is already there in the model that I have shared already on GitHub. So this is one, I think this is the one. Yeah, this is one battery model which requires this nominal voltage and internal resistance. But I think the right approach is basically getting into the like exact data of the cells that you have. Okay. Now, how do you find the cell data? So remember the goal, what do we want to find? Okay. So I'll go next. Okay. So just to understand the whole modeling of the lithium ion battery cells. So we were just talking about the discharge pulse. So if I bring that ECM model or the equivalent circuit model, okay, so there's relevance of each of the parameters. For example, this R naught is basically for the instantaneous response that you see over here. Okay. Then further, you have exponential relaxation, which is coming because of this time constant, which is having two parameters, R1 and C1. And then further, the open circuit voltage, which is EM, okay, this is bringing this constant value of the voltages. Okay, so this is what the response you get. This is one example of the discharge pulse. Now, what is the goal? Now, the goal to when we say parameterizing a cell is basically that we want to find these parameters, basically R1, C1, R0, and EM. These are the parameters we need. Now, how do we find that? So for that, we use called a parameter estimation technique. Okay. So as I mentioned that this is the model in Simscape. Okay. And then we have some data with respect to charging and discharging, basically, 100% to zero SOC based on different temperatures. We have different R1, different data that we require. Okay. Now, what do we have now? Okay. See, we have HPPC test. Okay. Assuming that you have HPPC test, like the data that I showed. And don't worry, if you want to try it out, I'll give you the data that we have, that the data that we have estimated. Okay, that we'll be adding in the GitHub repository. By morning, it should be live. Okay. Now, this is the data you can imagine that you got from the HPPC test. This is the model that you have it in Simscape. And then you keep on optimizing this until you get the convergence. Okay. It keeps on optimizing it until you get the convergence. Now, how do we do it? Okay. First of all, I think everyone understands that we should have a model. Okay. So that the model that I showed, that is a kind of a method that you model it. Okay. Now, further, let's look into the how do you characterize using a demo that we have. Okay. So I'll go back. So what do we do? So I'll just close this part and also close this part. Okay. And then we will just open the model that we have and we'll just go step by step. So let me see meanwhile if there are any questions. Yeah, I saw there's one question that in equivalent circuit of cell, what is the necessity of connecting R1 C1 and R1 C2 connect? I think that's what I was talking about basically, that there's a, I mean, significance. Why do we do that? Okay, so basically I showed that what is the significance of R1 and C1. Okay, because this will give you the exponential relaxation. Then further you have okay, the GitHub link will share. I mean later. Don't worry about that. I mean we'll share that. VT and V not see change. Okay, I'll come to back. I mean I'll show you the charging and discharging. There's a question around that as well. Let me just go into the model that we have, and you will see that in that data you have the charging and discharging. Okay, so I'll minimize this. Okay, now I'll show you the, first of all, the model that I'm going to open. I'll show you the basic, the fundamental approach, like how we, I mean, had R1, C1 and all those things. Okay, so let me open that model. Okay, so this is the charging and discharging data that you see. Okay, discharging, charging, charging, discharging, this is what you get. And then I think voltage plot I should have drawn, but I'll show you in the Simulink model. Okay, so okay, so this is the cell model that we have. Okay, in the cell model, what do we have is basically the same structure. Okay, and but in when you go inside the battery, you can see that this is a same, exactly the same thing that we drew: R1, C1, EM, and R0. So this is the, I mean, initially earlier we used to do it because that block that I showed directly, which you can use, it was not there. Okay, now okay. Okay, yeah. So basically, yeah, so you have this cell, and then what is happening over here is that you have the current pulse that we saw, and then you have, based on the current pulse, let's see what is the response currently with the parameters that we have. Okay, so we have just put some random parameters because we don't know what are the parameters. Now, if I just play this, yeah. So in the plot, you can see that what is happening is that you have blue one, which is the experimental data. Okay. And the yellow one is basically your simulated data. Now, why is it so? Why? Because the parameters which are there in the model R1, C1, and all these models, okay, these are basically not the correct values. Okay, these are not the correct values. We need to still parameterize it. Okay. Now, when it will be correct? Once both are converged. So let me show you how does it look like. Okay. So I'll just upload the estimated parameter that we have. Okay, so I'll just put this in place. Okay, I think so. When I do that, what happens is that it, not the C1, sorry, the EM values you can see all are being changed. These are not constant at all now. These are the already, because I have already estimated it. How we have estimated it, I'll come to that later. Okay, so I'll play it over here. Now I see over here that it matches. Okay, now it matches. Now the process, we need to understand that what did we do over here. Okay, so let's go around that. So I have one model. Let me open that first. Okay, So there's whole lot of videos which are there online available. Okay, I'm not going to run that optimization because it will take time. So what do we do is over here is that, let me just quickly see if values are loaded or not. Okay, so when you get the parameters, okay, so when you get the block, this block, in this block, what we are doing is we are defining this by some variables. Okay, some variables em, r naught, r1 and tau. Tau, what is tau? This is the time constant. Okay, and what is this? This is c1 into r1. Now, where are these values located, which are just initial random values? These are over here. Okay, you can see over here, R naught value is over here in the workspace, which is just 0.01 ohm. Okay, similarly, you have R1 value over here, which is again 0.005. So we have just put some random values over here. Now, the goal is basically we want to parameterize, or we want to find these values. Now, how do we do it? So what we do is that in Simulink, there are multiple apps. In the apps, we have something called as parameter estimation. Okay, we type it as parameter estimation. Okay, so it's a parameter estimator. We open this. Okay, so meanwhile it is opening. Any questions or any major thing that I see? Okay, there are questions, maybe, I think. Okay, so I'll come there. There's solver question which will come maybe later, but since I'm talking about the battery, there's a question from what about C1? It's not represented in the battery table base. That's correct. Okay, so basically, rather than that, what we are doing is we are actually using tau value, which is a time constant. So basically, this tau is R1 into C1. So this tau is taking care of that C1. Okay, so there are different modeling tech. I mean, it is still the ECM model. Okay, just that parameter we are counting it as time constant. Okay, so basically in this whole block, as you can see, you don't need a C1 value. Okay, C1 is basically represented by tau. Okay, not I would say tau represented, basically tau is a function of R1 and C1. So that is taken into account. Okay, so that is the time constant. So that's why our goal now is to find the time constant, the R1, the R naught, and the EM values. Okay, so I'll close this. I think our app is open now. So this is called parameter estimation, and this is a very powerful tool when you're doing some kind of modeling and you don't know certain parameters, but you know the requirements or you have some experimental data with you. Okay, so what we do is that we go into the new experiment. Okay, we click on new experiment. Okay, and then we specify the data. Okay, so what is the data? The experimental value is basically T. Okay, and the data is basically the voltage response that we got from the experiments. Okay, now once that is done, then after that you have parameters to be defined. Okay, so which parameters you want to estimate? So for that, what you need to do is you need to select. When you select this, it will open a window of all the parameters which are there in the workspace. So you click EM, R naught, R1, and tau. Okay, so EM, R naught, tau 1, tau. Then you press OK. And then after that, there is a option also for defining the range of all these values. If you know some kind of, I mean, I would say the max and the min values, definitely you can put the range over here. I'm currently not kind of going to simulate it, but just going to plot this, all the values over here. Okay, so now if you see over here, so I plotted, this is the experimental data that you have. Okay, so I'll also do one more thing. Let me just go to experiments. Okay, and here yes, parameters are set, and then add plot. So parameter trajectory. So what will happen is basically that it has two plots now. Okay, so what happens is that once you have added the experiment, this is the experiment voltage versus time. You have selected the parameters EM R0 R1 tau, then you run the estimate. Okay, you run the estimate and it will start optimizing it, and you will start seeing the convergence, okay, of the simulated data, as well as you'll also see the convergence, the convergence on the simulated data and the measured data, that you will start seeing. Okay. Now, and at the same time, how the parameters are being estimated, okay, over different iteration, that also you'll start seeing. Now, if I go here, I have just recorded a video. I would say it's an old video with the previous testing that we did, but I'll show you how does it look like. Okay, so you can see over here. Yeah, so it started. You have measured data, simulated data. This is the estimated parameter trajectory that you see. Okay, and it's getting started optimizing. Okay, there's a huge gap between the estimated and the experimental one. So you can see over here that finally when we go end of the optimization, it is converging. Okay. Now this was of a very clean data, but the data that I am using, I wanted to show you what is the result of that. So this is what it looks like. Okay. So you see over here, this is what it looks like when you run it. Okay, so this is the one measured and the simulated. It is almost converged. I have to stop it in between. Okay, and then you can see that how this EM, R0, R1, tau 1, all these values are being estimated. Okay, so once you estimate that, what happens is basically this is what you get as an estimation. So I have already saved. Okay, so you'll see over here that we wanted to estimate R1. When I click on this, these are the estimated values, cell data, which I got after I have run the optimization. So you see over here, I click and this value got changed. Even these all values are changed. These are no more constant values. Okay. Now, when I run this simulation, as you all saw, that it is overlapping with the values over here. So what does it mean? So it means that once you have parameterized it, you have the correct battery parameters in place. Okay, that is what it means. Okay. So I hope you got an understanding. Let me see if you have any questions. I'll take. Okay. Questions. Okay. So there's one question on how did you open the parameter estimation? So basically, what we need to do is that your model is set. Okay, you go to apps. Okay, so by default, this is how the tool strip looks like. Okay, you have a tool strip over here like this. When you go to the apps part in this, you will have you can type it parameter estimation and just click on this. That's it. That's what you have to do. Okay, you need to click on the parameter estimation. Yeah, so there's a question around the MathWorks, and yes, definitely. That's in our agenda today. Once we have covered these topics, we'll talk about the MathWorks electric challenge. Okay, so we'll talk about that. So there's another question that how did the C1 even R0 R1 value changed? So that changed because, as I said, because of the parameter estimation. So as you can see, when I ran the parameter estimation, this is a recorded video. Okay, when I ran this SDOs, okay, parameter estimation, what was happening? It was optimizing. Okay, when it is optimizing, after that, what happens is when it converges completely, these values, which are estimated parameters, these are automatically saved in the workspace. Okay, and I have already saved it, and I just sort of loaded that value in the model. Okay. Okay. Yeah, there's some generic questions. I'll take all these questions. I'll come back to this later. Okay. But any question like, uh, do you got an understanding like how we are estimating the parameters? Any major question around the parameter estimation? If you have, you can just put down in the chat. And don't worry, these models which I'm showing, these are also available on the as a shipping examples. All these blocks are available, so you don't have to worry about it. And yeah, if you have a cell data and you are having challenge in estimating the parameters, we can help with that. Yeah. Yes, we will talk about the SSD estimation. Yeah, we will talk about SSD estimation in the later part of the session. Yeah. Okay, I think I stopped sharing by mistake. Give me a second. Okay. Fine. So now let's do one thing. Once your cell is created, so what is there? So now you have a cell. Okay, the cell is in good place. You have the parameters all set. Okay. Now the next target is making a complete battery pack. Okay. Now making a complete battery pack is quite easy in MATLAB. Okay. So making a battery pack that can be done using a tool called battery pack builder. Okay, which is a part of the Simscape battery. Okay. So now uh, so what we'll do is we'll try to see that, see, we have understood that, okay, you have a battery pack, you can define the parameters and that your battery pack is all set. Okay. But in the pack, you have different configurations. Okay. You have you have cell. Okay. You have, I would say, different configurations. When I say like N series, M parallel, okay, all these configurations are there. There are different geometries of the cell. Okay, it can be a cylindrical cell, it can be a prismatic cell, it can be a pouch cell. Okay, and then what you have is you have parallel assemblies, you have modules, you have module assemblies and different pack. So how do we model is basically is that you start with cell, you go to parallel assembly, you go to module, you go to module assembly, you go to pack. Okay. Now, how do we do it? For that, there is a tool called Simscape battery. Again, this is based on the physical modeling system, which is meant for modeling battery systems, okay, and BMS systems. So without much time, I'll directly go to the tool and we'll show you that how do you model a simple battery pack. Okay. I'll close all the other parts for now. And then let's go to the battery pack block folder. Sorry. So you go to apps. Okay. In the apps, you have battery builder. See over here. Okay. So this is what it opens. Okay. So it will open a battery builder. Now, it starts, so there are steps. Okay, so there's a top to down approach. Basically, we start with cell, we go to parallel assemblies, we go to module, we go to module assembly, and then you make a pack. Now, for example, if you have a prismatic cell, okay, I don't have the exact values. I'm just taking some random, I would say, configuration. I'll just start building on top of it. Okay, so I go to cell, okay, and let's take it as some BAJA cell. Okay. Then you go to stacking axis. I'll just keep it as it is. Here you have options for cylindrical, pouch, prismatic, and all those other options are there. So I just take the prismatic one. I'll keep all the parameters, the default parameters. You can change as per your requirements, as per your cell geometry that you have. And then what happens is that you have cell properties, you have mass, capacity, energy, you can feed in over here. Then you have parameterization. Now see, we just learned that how do you parameterize a cell based on the HPPC test that you have. Now, in this one, what we have done is we have different uh, cells which are already loaded over here, okay, from different companies. The parameters for those are already loaded, okay. But I'm not sure that you are going to use the same cell or you are going to get this configuration, that cell in this case or not, because this is more, I would say, industry specific. If I just take Panasonic and see the options, so these are the options. But I would say, I mean, don't worry about that. If you don't have it, just keep it blank as it is. Okay. And then you can just proceed further. There are other options over here that how do you want to model, I mean, cell options. One thing which I think you should do it over here is basically, just give me a second. The, I think, 1 second. SOC, and you have, yeah, the dynamics part of it, basically the cell dynamics. So in this case, what you need to do is, see if you remember, so dynamics part means what? Okay, how many time constants or how many RC pairs. So if you remember, if you are parameterizing your cell based on the data based on one RC pair, just select one and you can further proceed. Okay, I'll just select one and I can proceed over here. Okay, and then you can see that how you get a cell like this. Similarly, after that, what I do is I get into the parallel assembly. Okay, I'll go to parallel assembly and then I will just name it as BAJA E, that is parallel. Select the cell on which you have to build. So the cell that I built was BAJA cell. I'll put it like this. Okay, and then I'll just if I just press OK, apply without adding any, I would say, in parallel. I just want to be in series. So in that case, I just go to further module. Okay, again, I'll just name it as BAHA M, that is BAHA module. Select this parallel assembly, that is BAHA P. Press OK. Okay, and then further number of series, let's see, let's check that. I want to have 7. Okay, and I press 7 over here and press OK. Okay, and we keep on doing this. Okay, and until based on the structure that you have. Okay, that's how we do it. So further we go to different step module assembly and pack. Now I have a session saved. Okay, let me open that. Okay, so I hope you got the understanding. So basically it's quite easy. You go from cell to parallel assembly to module assembly, and then you create a pack. Now I'll show you that what is the important thing that is required in this modeling part. So I import over here, import a mat file, which is already a saved session. Okay, so let me just, I think this is the one, I guess. Let me just see if it opens or not. This is already built. Okay, just since we don't have much time, okay, that's why I'm kind of like opening the session. So again, if I go into this, so this model had BAHA cell, then BAHA parallel assembly, BAHA module. Okay, the module was there. Then another module assembly. Okay, so further we connected into series. So basically it has how many? 14 cells, I get 1, 2, 3, 4, 7, 14 cells. And then the BAHA pack. So this is the pack that we have now. Now, the important thing over here is that this can be further created as a library. Okay, so when you click on this, it will create a library. So when I click on this, okay, so it will create a library and it will ask you where do you want to save it. Okay, so when you click on create library, it will create a library. So when I say create a library, what does that mean? So let me go to the library that has been created. Okay, so over here, so this is the pack that is exported when you use this button. Okay, so when you use this export button, sorry, create button, so this will give you this battery pack. Now, this is the battery pack, which is actually comprising of cell, parallel assemblies and modules based on the pack that you have on your vehicle or the pack that you're working on. Okay. Now, over here, if you see that if I just click on this new, okay, I can go over here and then you can just click on this. I see some, okay, let me just take a break of it and I see some hand raised. Okay. Okay. This few hand I saw raised. If you have any question, you can put that in the chat. Otherwise, there's one question that when I worked with the same, it showed me that we can't create a battery pack. Yes, this can happen if I would say the connections are not making sense, especially, for example, okay, that you are not taking the proper topology or you are not connecting it properly, cell, series, and parallel, then it will create a problem. Okay, there's a question sort of in parameterization, can't we load our own battery parameters? Yes, definitely. If you have your own battery parameters, definitely. If you have all the parameters, I mean, there are different, there are also manufacturers, those who give that, I would say, sort of table. Okay, all the parameters they give, definitely you can do that. Definitely. This is a process that we are kind of teaching all the students that this is how it is done. Okay, but those who, yes, okay, I'll come. Okay, the question was not completed. It was, can we load our own parameters in the battery builder? Yes, you can do that. Okay. Fine. So now, okay, so there are questions which are actually which I was going to talk about. Some interesting questions I see that one question is that can we add the parameters in the battery builder? No, directly. See, what would happen is when I go to cell, okay, okay, we are happy to see the questions coming. These are really good questions. So when you go to cell, okay, you don't have option for custom one. Okay, I'll tell you how to do the custom one. Okay, I'll come to that. So either you can keep it none, okay, if you don't find any cell which is from this list, you can keep it none and proceed further. Once you have all done and you have got the battery pack, then here you can change. Like for example, so this is the battery pack, the Baja pack that I exported using the battery builder. You go over here, you go to this, and this is a little bit of manual thing, which is something we are also working on it as a product. Okay, so when you go over here, so if you remember, this is the same set of values that we estimated. Okay, so here you need to change the parameters. Okay, here you need to change the parameters. Okay, so that's what you need to do. So in this module, okay, here you need to put all your cell. Okay, here also you need to put your cell data over here. So that is, then you can say it is the your customized, I would say, the cell data that you have put. Okay, I hope I answered that question at least. Okay. Okay, so that is one. And then there's another question that how to activate the thermal port. Yes, you can do the activation of the thermal port. For that, what you need to do is when you go to the, let me just, okay, when you go to here, okay, so you need to thermal dependency, you have to put yes over here. Okay, you need to put yes over here. And then further, what you need to do is that when you go to parallel assembly, here you will have thermal options. You need to select all these intercell path, radiative path. This, once you activate all this, then your battery pack will have that uh, ports for the thermal modeling. Okay, so I'm just talking about the thermal port. Okay, basically thermal, sorry, the battery pack modeling. I'm not talking about the thermal part, but if you activate all this, it will be certainly done. Okay. So yeah, I need to activate. If you don't activate, don't expect that it will be shown over here, over there. Okay, further questions? Do we have any? Okay, we'll come to that. There are some questions around the challenge. We'll come to that. We'll come to that, Prasad. I see that question coming. We'll come to that. Don't worry. Okay, we'll quickly cover all these topics and then we'll have enough time to do that. Okay. Okay. Okay, I'll come. Fine. So I hope you got an understanding what we are doing here. Okay. Then, so with this, okay, so battery pack, I think you got an understanding what we are trying to say. Okay. Now further, 1 second. Okay. So there were some questions around the SOC estimation. Okay. Now in this, basically, I mean, your cell is set. Okay. You have characterized the cell, you have made the battery pack, and you have further, you have also, what you have done is you have also parameterized it as per that. Okay. Once you have done that, then the next step is that if you want to estimate the state of charge. Okay. Now, there are different methods. Okay. There are different methods to sort of find the state of charge. Okay, one is the open circuit voltage. Then you have the Coulomb counting. Then you have Kalman filtering. There are nowadays AI based as well, and there are certain hybrid methods as well that we are seeing. Okay, now what we have done in Simscape battery is that we have added certain blocks over here. Okay, so let me just close all these. And don't worry, I am seeing the question around the challenge. I think once we get into that, I think we will, you can speak as well and we can have conversation. Okay. Okay. So what we have done in Simscape battery that we have provided enough blocks, okay, that can be used as a estimators. Okay. So these are the blocks which are there in the as an estimators. Okay. So you have Kalman filtering. You have in Kalman filtering, Kalman filter itself, you have multiple options, but I would say don't get confused with multiple blocks. I would say you can just use one SOC estimator based on Kalman. This is the simplest one. And then you can also compare with the Coulomb counting block that we have. This is these two, and those are enough. You don't have to kind of go every, all the, blocks, because if you go into all the blocks, it will also require a lot of data. Okay, so don't get confused. If you are successful in using this SOC estimator Kalman filter, then you can definitely explore other blocks that you have. But as a starting point, you can just get started with the SOC estimator for the Kalman filter. Okay, so to give an example, this is one model that we have. Okay, and it will give you the understanding of correct understanding of how do you use that block. So, okay, fine. Okay. Now, intentionally, I have added a thermal port over here. Okay. Because there are few people, those who might be looking into the thermal part. So again, see, this is the one that this can be also replaced by a battery pack that we built. But for now, we are just sort of like using this simple battery pack. Okay. Now, in this one, there are two options. Okay, one is Coulomb counting, one is the SOC estimator. Now, with the Coulomb counting, the thing is that it is not taking the dynamics of the battery pack into place. Okay, like for example, if you just go in there and you go to the help and you can see that how it has been modeled. Okay, so it is not taking the dynamics in place. Yeah. So it is just basically the formula that we are using. So this is the regular formula of SOC calculation based on the Coulomb counting. Okay. Similarly, when you go to SOC estimator, you will see that it has more parameters. Now, if I run this, okay, so the major difference that you see over here is this part. Okay. Now, see over here that what you get over here from Coulomb counting is this. So let me be clear that the yellow one is the actual SOC, the actual state of charge that it should have. Okay. or you can say the experimental state of charge. The blue one is the Kalman filter based, and the orange or the red one is basically the Coulomb counting. So you see here that since it is not containing or taking into account the dynamics of the cell parameters, okay, it is just constant, okay, it is having the same nature of the pattern, okay, but it is not there because what happened, we started with initially state of charge estimation as 0.8. If we would have started with 0.5, okay, let's do that. Okay, for example, I'll start with 0.5. Okay, so 0.5. And now when you simulate it, you see over here that now it is good. Coulomb counting is also very happy and doing the job that it does. Why? Because it has started with this, okay, with the same state of charge estimation. So what is the problem with this? The problem is that in real scenarios, when the vehicle is moving and you have some noise, okay, so what will happen is the noise will be same, okay, that I mean, the effect of noise will be same and it won't try to converge it, okay. Whereas in your state of charge estimator using Kalman filter, it will take that noise into account and it will try to converge and reach to the actual state of charge. So for example, I just put 0.28 over here back and I'll again simulate it. And this is what you get. Okay. Now, using the block, okay, I think everyone knows how to use the Coulomb counting block. It is quite simple. You just need to feed your cell capacity and it will get the data. And then you have the SOC estimator. So in this, the important thing is the parameters. Okay, then only it will work. Okay. As I said that there are students, I mean, there are multiple teams. Okay, they are already having the parameters. If they have well enough, you can just have your own parameters. Okay. And don't get confused with the temperature. Many a times you just have one temperature in place. Okay. So don't get worried of that. Okay. Don't get worried of that. You can just have same temperature of some room temperature. And then based on that, it will basically 7 cross 1 matrix will be in there. Okay. Further, or you can, if it is throwing error that it requires minimum two temperature, you can just have same temperature, then the matrix will be 7 cross 2 over here. Okay. So now here you must be thinking that, okay, I don't have temperature values, this and that. So let's do one thing. Okay. You can also as an option. Okay. Now I'm moving more, I mean, talking more in terms of challenge because a lot of teams may not be having all the values. Okay. So if I just put constant, okay, it will be 25 plus let's take 273.15 converting to Kelvin, and then you can have that temperature constant and you can put it over here. So that works. That is also fine with us. Okay. We understand that you may not be having all the values. Okay. So it is okay. So even if this circuit is removed completely from here, if I remove all this circuit, okay, it should run. Okay, it's throwing error because I need to deactivate this part. It should run. I think some value I have messed up. Give me a second. Oh, I think I deleted the solver configuration. That was the thing I think was missing. It should run now. Okay, yeah. Okay, perfect then. Okay, so this is what you can use. Okay, even in the challenge. Okay, you can be used on that. Okay. Before we just okay. Okay, fine. I don't see any major question now. Okay. Okay, so quickly now what I will do is, so this part is over, the Kalman filtering part. Okay. I will just quickly move to the powertrain model, okay, that we have, and then we can just have discussion around the challenge that we have launched. Okay. So yeah, so what I think you have is basically all the models are basically over here. Okay, electric ATV. Okay, so this is the model that is in there in place. Okay, no. Research for. Yeah, this was a video that we recorded. And it should have. Yeah, okay. So the model is here. Okay, so this is what the model I'm going to open now. Okay. In this one, there are two models, but I'm going to model the generic one, okay, which requires generic motor. So if I open this and I do. Okay, so regarding the electric powertrain, I think we have spoken a lot about the whole battery. That was an important part. Okay, now in this model, okay, we using the drive line. What we have done is we have modeled the simple longitudinal vehicle dynamics, which is in place. Okay, and it has a brake. So this is basically taking care of the vehicle body, which is taking care of the mass and the a number of axle and the distance from the CG of the front axle and the rear axle. And the center of gravity, this is taking care of the tire blocks, and then it has a brake. Further, then you have electric powertrain. So once you have the battery pack set, okay, over here. So I have in this model, it's a simple one because you have to kind of parameterize as per your vehicle parameters. So once you have the battery pack in place, then step down, you have a DC-DC converter, you have a motor and drive. Now, to be noted over here, we are not using any motor or BLDC. Okay, so there's PMSM motor. Okay, over here, there's BLDC. Okay, I'm not talking about the challenge now, but I'm just talking about that if you want, you can use it, but you should have the parameters for this PMSN and BLD. So that's why we have kept it simple so that if you have to define electric powertrain, that should be based on a simple, I would say, low fidelity motor and drive model, which can be modeled based on the maximum torque, okay, maximum power, time constant, and some other values of speed at which efficiency and motor and drive overall efficiency. Okay, so that's why we have kept it simple. Okay, after that, it depends upon your drivetrain. Like there are students having four-wheel drive, two-wheel drive, rear-wheel drive. Okay, okay, they have CVTs, they have different powertrains. Okay, but we have kept it simple. Okay, because we don't have exactly those data, so we have kept it simple. So in a nutshell, basically, how do we do it? Once we have made a vehicle dynamics model, okay, then we go to the powertrain. Powertrain has a battery source, a DC-DC converter, then you have motor and drive, and then you have a simple gear, and then you drive the whole model like that. Okay, and then further when we drive it, okay, you can see over here that how do you get the performance of the vehicle. Okay, so basically the drive cycle is the reference signal, and the velocity that the blue color is basically the velocity that you're getting after the simulation. Okay. So yeah, and all these, I mean, we were just looking into only the electrical library, but to design a detailed powertrain, when you go into this Simscape, okay, you have electrical that we have gone through. Then you have driveline. In driveline, you can see brakes, clutches, gears, all these things are there. If you want to utilize this, you need to utilize, I mean, you can utilize. Remember that the connection should be proper and the values that you're feeding should make sense. Okay. So yeah, so what I'll do is, since there are multiple questions around, I would say challenge, okay, and I can take up those questions now. Okay. Okay. Then, um, yeah. So Rhythm, if you're there, I think if people want to speak or they have questions, either they can put that in the chat or depends like how do they want to. I mean, they want to go ahead. Okay. If they want to speak, they can speak or they can put the questions because now it is a time that we can have open discussion about the challenge. Okay, meanwhile, so in this block, okay, see, in this model, the battery pack is, is a simple model actually. Okay, it's a simple model. This is the battery block that we have. So we have just mentioned over here the nominal voltage and all. We have not added the dynamics over here. Okay. See, if we do everything, then, I mean, for you, won't be anything to do. That's why we have kept it like this. Okay. We have a solution model. Okay, we have a solution model and we have a detailed model for this. Okay, with the pack and everything. Yeah. Okay, so there's one question over here. The question is basically that how can we design the parameter pack in MATLAB as we don't have the parameter values? See, if you go to the documentation, let's see. Okay. So in the documentation challenge, we have said that design a detailed battery pack, which uses a simplified. Your task is to replace a placeholder with a realistic battery pack model that mirrors the specification of your team's vehicle. Okay. So what you can do, okay, I think we'll also add that clause in the document as well. So what you can do if you don't have exact values over here, okay, so what can be done is that at least you can try to feed all the values. These values, I think any teams can have, okay, these nominal wattage, you can have that, okay. And if you want to try with the battery pack, okay, the pack that I was talking about, we are going to add the parameters in the GitHub repositories over here. So okay, 1 second. Yeah, we will add the values in this folder. Okay, the estimated parameters. So if you want to use that, you can use that as well. Okay. So there's a question around, can we, okay, let me go one by one. There's a question around PMSM motor if we have the values. Yes, if you have the parameters for your PMSM motor, you can add it, no problem. Okay. Make sure that you have the proper connections and you're able to simulate it. Yeah, see, I would say we are not necessarily asking for all of the students to go into the detailed motor and all, because we also know the main task for the student is basically to build the car. We don't want you to spend a lot of time into experimenting with this. If you have it because you don't have much time. I think the 21st December is the last date. I think just go ahead with parameterizing your motor and drive. And the other important thing is that this powertrain is quite simple. Okay, if you have differential, if you have anything major, you need to add that in your vehicle as well, in your model as well. Yeah, you can estimate the range, and that's one of the thing that has been given as a task. Okay, so that can be done. That can be definitely done. There's a other question on how that state of charge block is formed. So, so to answer this, all these. Okay, let me just take that. Get this. So those who want to learn that how these blocks are built, like SOC blocks, you can just go inside the block. So in terms of keyboards, you can just press Control U. Okay. And then you can further get into Kalman filtering, and then you can see that how it has been modeled. So it's these blocks are open. Okay. So you can definitely get into that mode of exploration. Okay. Then changing the simulation time, the block set shows an error. Can you please see this is, I mean, while changing the simulation time, the block set shows an error. Can you please? This is something that, I mean, I would say the live session, it is difficult because we need to see the model, like what is the issue? Okay, what is the issue? I would say that is the main thing that we need to understand. Yeah. So let me do one thing before I close, I mean, before I forget. Okay, I'll quickly just uh, put down, let me just add the PDF file of the presentation. Okay, so that I don't forget and miss this. So give me a second. Because this has the links to the models, the files and everything. I hope in the chat you all can get the access. So okay, I don't think I am able to uh, put that as an attachment, but I think I'll share with the organizers and they can share back with you. Okay. Anyways, no worries. Yeah. Okay. So let's go to the question further. Okay, in order to gain proficiency in using MATLAB, is the courses which is available in MathWorks website is good? Yes, I mean the courses which are there, they're definitely they're built by our professional training team to get the proficiency. I think definitely you can do those trainings, but at the same time, make sure that you do after doing that do some projects, so that will help. So there's a question. We can make full powertrain with drive cycle, longitudinal driver, vehicle body and a gearbox. Yeah, I mean, definitely you can make a full powertrain with drive cycle, longitudinal driver, vehicle body and gear powertrain. Yeah. Okay. Okay. Yeah. So I think the questions that we have like, gone through. Okay. So the challenge. Okay. The challenge basically for the BAHA students. Okay, this is for the BAHA SA India students. Okay, so this is the challenge that there's a template model. Okay, and you need to complete certain tasks. So the two tasks are design a detailed battery pack model and modify the powertrain subsystem to match your vehicle and demonstrate performance of your vehicle using simulation plots. Then you have some cash prizes and these are the key dates. Then the organizers have also shared the documentation with you. So this is the documentation that we have shared with their team. It has, I guess, almost all the details. All the details are in there. Okay, so it has challenge overview, procedure, and important dates. Okay, so if I go step by step, so this is the challenge overview. It will be done in two stages. Okay, first you have to submit a short report and the models with the task that you have done. Okay, and then after that, up to 10 teams will be shortlisted and they will be presenting during the IBAHA physical event to the MathWorks judges. And then you have some awards. These are the important dates. The submission should be done by December 21st. Okay, and we'll try to announce the result for the top 10 teams by December 27th. Okay, and this is the details about the challenge statement. Okay, so first is designing a battery pack. Okay, replacing it with a battery pack. And what do we need is basically state of charge, voltage and current measurements, integration with powertrain, and performance visualization. Further, what we have done is that there are many technical resources that we have attached with this. You can have a look into. These are really good resource and on-ramp courses that can help you get started and complete the tasks. Then you have modify the power. The next task is basically to modify the powertrain subsystems. Okay. Now this is going to be, I would say, a tricky part. So you need to invest time in this. Okay, because it will depend upon how you are parameterizing it, and then how you are uh, making sure the powertrain that you have on your vehicle is same replicated over here. Okay. And then some expected outcomes we have done over here. And then in terms of evaluation, this is how it will be evaluated. So what we'll do is we will have a drive cycle which will incorporate, when we say drive cycle, so in this model, as you can see, this is the drive cycle. Okay, this is a simple drive cycle that we have. Okay, that we have put it over here. Okay, if I plot the drive cycle, this is how it looks like. Okay, this is how the simple drive cycle is. Your model, sorry, your model will be tested on a drive cycle, which will incorporate start, rapid acceleration, maintain speed, hill climb, maintain low speed, and all these things. It will be tested on. Okay. Then further, this is how we will be evaluating. So out 50 marks will be there for the accuracy of tracking the drive cycle, then battery pack design, and then the electric powertrain design. Okay. And then there are further more details, and the final score will be based on the stage one, which is having 60% weightage, and the score two, which is having 40% weightage. And then we have further added more details to this. Okay. So, and or what kind of files we need, all these details are there in the documentation. You can further go through it. Okay. Further. Uh, I see one question that okay, let me ask a question. Is everyone in the call, those who are from BAJA SA India, are aware of the challenge and they know from where to get the document? Can you just press yes or no? Okay, yes. Okay, fine. Okay. So I think those who are asking where to find the document, that is, I think in the forum, they have added in the forum. I definitely remember that, and it has been informed to the students. Okay. So yeah. So I see a few of the people, those who are writing yes, can you just type in where you have got the document, so that, because I don't have the access to those forums, so you can just tell them that, okay, where they can find it. Okay. So there I see a few of the names writing yes. So you can help your other friends, just let them know where you found the document. Uh, and then further, and then if you don't, I mean, other option is that you can just write me, just drop a query on this email ID, racinglodge@mathworks.com. Okay, once I receive your email, okay, I'll just quickly send you that document. Okay. And yeah, those who also are looking forward to the slides, I can also send that if you want. So let me put that email ID over here. So I mean, there's a question that, are you talking about the GitHub repo? There are two things. On the GitHub repository, models are there, okay, which we showed you that over here. This is the GitHub repository on which models are there. Okay, these are models can be used by anyone, BAHA, non-BAHA, participating in the challenge or not participating in the challenge. Okay, that is one thing. Another thing is a challenge document, the challenge that MathWorks has launched in collaboration with BAHA a few weeks back. Okay, so GitHub repository link, I think I have showed you. I can share you again over here. Okay. But the document for the challenge has been shared on the BAHA forum by the organizers. You can find it over there. Okay. If you haven't got it, I have also pasted over here the email ID, that is racinglaunch@mathworks.com. You can just put a query that you want the document. I can send you the document for that. Okay. Okay. Now further, now I see there are certain hand raised. Okay. So let's see who wants. So I see a hand raised from Devakar. Do you have any question? There's another, I think, Devyani again. Yeah, if you can speak, Devyani, definitely. I can allow you mic if you want to speak. Yeah, I have allowed you. If you want to speak, you can speak. The people, those who are raised the hand, I'm just allowing the mic if you want to. Okay, so where can I find the session recording? uh, Rhythm, I mean, this I have to ask with the organizers. Okay, if you're there, so will this, I mean, this will be provided to them, right? How is it?
We need to check, sir.
You need to check. Okay,
I
fine,
need to
no
check
worries.
on the scene. Yeah.
Yeah, okay, fine, fine. Okay, I hope everyone got the answer. Yeah, okay. Fine. Okay. And then there was one question, and will you tell about the SOC block which was there inside the battery? So yeah, I mean, inside the battery, I guess you're asking for this one. So this is a Coulomb counting one. Okay, so this is a Coulomb counting. If you go over here, okay, this is a Coulomb counting one. That's a simple one that we have added. Okay. Okay, so fine. There are further questions. Can we get the PPT? Yes, definitely you can get the PPT. Okay, let's do one thing. I would say that uh, just um, you can
Sir,
just, yeah.
for the drive cycle, which type of drive cycle we need to use there?
Okay. Who is this? Sorry, Mantram. Okay, fine, perfect. Okay, good question. So see, 1 second. Yeah, you don't have to collect any drive cycle from you. See, one thing is that, okay, I'll one thing is that you can create a drive cycle based on the explanation that we have given you. Okay, so which will have all these. Okay, we will do one thing. Okay, because I have received, I think, 3 4 questions, and we have the drive cycle. What we'll do is, for your testing purpose, we will do one thing. For tomorrow morning on the GitHub repository, we'll add the drive cycle as well, so it will be uploaded over here. Okay, we'll add the drive cycle. Okay, and we'll also inform the organizer just to
Okay,
put a
sir.
note in the forum. Okay, we'll do that. Okay, yeah, I think it was I mean, I was supposed to add, I think I forgot. Which type of synchronous motor block? Yeah, we need to check, Prasad. I think what you can do is you can go to the motor block set, or you can go to the Simscape electrical. You can go over there, and then you can just see around, like, which one do you like, which will be close to for your application. Okay, so okay, those, I think, Mantaram, you can raise. Okay, you have spoken.
Hello.
Fine. So yeah, hello. Who is next?
Yes,
Prasad.
sir. Hello.
Any who wants to go next? Mantram, you want to go next with the
Yes,
question?
sir.
Yeah,
Yes, sir.
go ahead.
Sir, we tried modifying the powertrain block, but
Mhm.
after modifying some parameters, we are finding that the solver block in the motor controller and the solver in the battery are not converging. So we can't figure out what is the error behind that.
Okay, so what you do is, okay. See, I mean, the solution generally what we do is like we can share the model and then we can work, but this is a challenge. So it will be, we can't do that. So let me just tell you one thing. Uh, I'll give you a sort of a way which will help you debug the issue. Okay. So give me
Okay,
a
sir.
second. Find it. Give me a second. Let me search that in my system. I'm just forgetting the app name. Okay. Yes. Okay. Now I got it. Sorry. So what you can do is over here, when you go to simulation, okay, in here you will have it's a tool called Solver Profiler. Yes. Okay. So what you need to do is if the solution is not converging, okay, go to the Solver Profiler. Okay. In the Simulink tool strip, you have debug. Under debug, you will have Solver Profiler. Okay.
Yes, sir.
You open Solver Profiler and run that. Okay. Once you run that, okay, what would happen is it will run and it will show you all the like error that you're finding. Okay, all those things that can be done. Okay. So it is slow or it is not at all like it is throwing error. How is it? Or
Actually,
it
sir,
is
it
running for
runs
some
for,
time.
yes, sir. It runs for almost 20.2 second and then it stops.
So okay. So you run this and try to see. So what will happen is see, let me if I run this model, let me see. It will show you some of the zero crossings, okay, and where there's more stiffness, okay, where you can, if you see that there's a lot of stiffness in some of the blocks, you need to figure that out or maybe reduce the value. That's how you do it, okay. Like for example, see over here, it will give you some kind of analysis and solve exception. It will suggest you some few things, okay. So it will be giving you more information. So I'll do one thing. You can also do one thing. There is a nice video on Solver Profiler Simulink. Okay. Yeah, this is the one video I think I recorded a few years back. You don't have. Yes, I'll share this video also. So in the chat, you can have a look into it. Okay, perfect. Who wants to go next?
Sorry, sir, but I had another doubt also.
Okay, go ahead.
Yes, sir. Another problem is initially when I use some default parameters and added the parameters for battery,
Mhm,
motor, and the drive shafts, then we are getting an error that the range is almost zero, or we can say 300 meters or something, and velocity
mhm,
also drops to zero. But the drive cycle is as it is, which is as the input. So probably we tried configuring that. Is it the problem in the battery or is it the problem in the motor controller? So we plotted a graph for battery current discharge. So we got that
mhm,
the charges are going. So battery is working. Then we got into the motor controller.
mhm,
But through in motor controller we can't get a feedback that is it a working or not. So for that,
mhm.
can you suggest any idea?
Which motor you're using the simple the block that we have put or you have added your own motor?
No, currently we are using the simple block.
Simple block, okay. Okay. So the issue basically is that so what is the like you're getting the error or it is not I
No,
mean
sir.
the
It
uh
would run for all, if we run it for 50,000 cycles, it would run for that. But the range would be 0.3 kilometers, and the velocity would be 0 to 0.3 kilometers per second only.
oh, okay, so less, okay, okay, okay. Mm, okay. And it is matching with that drive cycle you're saying.
Yes, sir. So, sir, the SOC is dropping, but it is not dropping like as it would in real life. So there is problem where the power is not getting out of the battery.
Mm, yeah. You can do one thing. You can check into some parameters in the controller. Okay. So you
Okay, sir.
can like it's again very generic that we have kept. Okay. And then what we have done is in the PID we have a saturation over here. You can also see if you want because we have put a limit over here. You can try that. Okay. I'm just giving some hints. Okay. I'm not sure that this will work or not, but I'm just like trying to give some hints. Okay.
Okay, sir.
See, I mean, overall, the thing is that this is like the challenge that we're it is not that I would say easy. It is definitely challenging. Okay. So good that at least like you are approaching your all of the team members are approaching because and that's why we haven't made it mandatory. It is okay. It is but at the same time one thing we can say that it will make you learn a lot of things once you I mean kind of deep dive and try to debug things. Okay. Yeah. Okay.
Okay, sir. Okay. Thank you, sir.
Okay. Who wants to go next? Okay. Prasad, I see you are the second I mean number. You want to go next? 1 second. Let me unmute you. Allow mic. Yeah, I have allowed you mic. You can unmute yourself and you can speak out if you want. And then for Devyani as well, I'll allow mic. Okay, yeah. If you want, you can unmute yourself, Prasad. No, now you should be able to turn on your mic. There's a you need to you see over here. You need to just click on this. I think should be done. Okay, or on your Teams on the top, you can see over here, unmute yourself, like okay, then you can speak. On the Teams, I think top right, your mic option will be should be there, and then you can do that. Okay, meanwhile, how about Devyani, if you want to speak, you can speak. And then
Hello, sir.
yeah, go ahead. Yeah.
So actually, while I tried to change the values in the block set which has been provided by you, I tried to change a lot of values over there to match my things, but I was able to find that none of those outputs were changed, which I'm getting
Okay.
into the graph of
So
velocity and
which values did you change in that case?
actually, and for at the very first place, I changed the values in the motor and then
Mm-hmm.
battery configurations, the current capacity and all. I
Mm-hmm.
tried to change that also. I even tried to change the braking force, but I wasn't having great idea of that. So I just
Mm-hmm.
tried to go with motor and battery, but I wasn't able to find any of the change over there.
Okay. Uh,
And
hmm. That's weird. I mean, so you're saying that like it is not changing any velocity or any values, right, for your
so, like,
system
can
side?
you please tell that whether I need to do the changes in the vehicle data sheet which has been provided or in the model itself? Because I
See, I
tried
mean, if
both.
you, for example, see that script is there, okay, you can definitely change that. Basically, what it will do is it will automatically change these values, okay. So option is either you can go directly and put the value over here, like here it is 1. So I can, if I want, I can directly put 0.5. Okay, that is for convenience actually. Okay, but if you want to just use directly go into the block and you can do that. Okay.
Actually, I
Okay, so.
tried both the things, but
Mhm.
the default model which was being given by you and the one
Mhm.
which I made changes isn't showing any difference in the results.
Oh, you're saying that there is not much difference, is it? That's what you're telling.
Yeah, there's no
Uh,
difference whenever I do the changes.
that's weird actually, because depending upon, I mean, how about is it because see, this is a simple powertrain. Do you have the same powertrain? Like I would expect that
No,
people
no,
to kind
sir.
of like work. Yeah.
Like, no,
So
sir. The
Mhm.
powertrain model which has been given by you is very different from what we are using in our vehicle. That's why I asked you, like, can we use the PMSM motor directly?
Yeah, so if you have the parameters of the PMSO motor, definitely. We don't want to complicate thing because already see,
Okay.
already the lot of people are not having a cell data. There are some of the, but still
Mhm.
we'll add some data to that. But what I'm trying to say is that like we didn't put that PMSM thing because not everyone is having. If we put that, then it will be little bit, I would say, biased towards those who are having the PMSM data, right?
Okay.
Okay, that's why.
Uh, so,
Yeah.
and there is one more doubt which I was facing is that whenever I change the stop time, like for now, you have kept it for nearly 150 seconds.
Mhm.
When I take it to the battery range, what my battery life is, that is 1 hour, it
Mhm.
starts simulating, but at 360 seconds, it stops and shows an error. Up till that, it runs. I don't know why it is showing so.
So yes, telling that it just, I mean, you are putting how much is simulation time you're putting it over here?
So for 1 hour, 3600 seconds, I'm putting over there.
Okay, okay,
Uh, but whenever it starts simulating at 650 seconds, something it stops and shows an error over there.
okay, 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 okay. 1 second. Just let me see. I'm just checking one thing. Just give me a second. And it's changing. Just see once that, I mean, in your model, when you're changing this value, okay, like for me, it is like 150. And how about the drive cycle? Is your have you changed the drive cycle also?
No, so not yet. I haven't tried
So
that.
the data also should be have, I mean, you should have that data for that much of drive cycle. Okay,
Yeah.
so the I would say you can have repeat cyclically, just
Okay.
check those values. Okay, should work. I mean, it shouldn't be a problem. But in case if you're still having that or anyone, I think I saw one more question regarding the time thing. Just put send me a question on that racing launch at mathworks.com. I can have a look.
Shall
Okay.
I mail it, sir?
Yeah, you can mail that. Even I think anyone, those who asked the simulation time issue, that like we can have a look into that. Okay.
So there is one more concern of mine that when I am doing the battery modeling in Battery Builder app, it is not allowing me to create a battery pack while I am choosing all the required parameters which I need.
Uh-huh. So you have created a
So,
battery pack, right?
yes, yeah. So I tried. It's like when I entered till modular assembly, I was still there. And after
Hmm.
that, when I tried to create a path, it's showing that you can't create a battery pack
Oh,
while applying the
that
changes.
data that error you got in the battery pack builder, right?
Yes, yes, sir.
That that is for sure that is happening because of I think some not parameter, I would say some configuration that you would have taken. It's a common, I think, error that people get. So what I would
Okay.
suggest is uh, try to debug, go step by step. Okay. uh, See, okay, what is the like how you're modeling from the cell to parallel assembly to module to pack, and which step, by the way, you are getting that error, like are you getting the
So
step?
at the last step, yes, sir. Actually, I'm starting from cell, then parallel assembly, and then mod. Everything is fine, but when it comes to the last step, that is creating a battery pack step, last
Mhm.
one. I'm facing that issue over there.
Okay, 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 fine, fine, fine. So that, I mean, so basically while battery, I think there should be, I mean, could be some issue. I think I'm missing some step. Generally, like if you have reached to that much step, you shouldn't get without any error. If you have got it, like shouldn't have it.
Like it's not
Yeah.
showing any error till last step, but whenever I try to create a battery pack, it's showing me error in the last step. It's not allowing me to do that.
Okay. So you do one thing. Okay, because I mean, uh, I won't ask you to put the query on racing launch. Okay. So you can put that because it is more of a, I think the app, maybe you are having the issue. I am not sure about it because I haven't seen that what you and your team have done. Okay. So to just, can you put that query? I mean, you can do one thing like you can, okay, you can send the query on racing launch, the email ID that we gave. But if we see that that is something that can be figured out, okay, by the student team, we will
Okay.
let you know that you need to figure it out. There is a solution around it. But if we see that there's a bug in, I would say, backend of some coding and all in the product, then we can kind of give you a suggestion, okay? Because we
Okay,
have to
sir.
be fair with all the teams, okay? Yeah.
Okay, sir. Okay, sir.
Yeah.
I'm fine with it. Thank you
Yeah.
so much,
Okay.
sir.
Thank you. Thank you. Okay. Okay, fine. Any other? Okay, let me see the chat. Okay, so you have, since the model, okay, since there's a question from Sriram, since the model is configured as a tailwheel drive system by default and our actual vehicle also uses the same configuration, we only need to enter the required parameters. So need to modify. See, if you have, it won't be that easy. What we are going to check is basically that, okay, that it should be the exact parameters that you're going to put for your vehicle. Okay, we'll have a testing on the drive cycle, and also there's a task for also completing your the pack design as well, the SOC estimator as well. Okay, so see, a lot also depends upon when, I mean, let me just be clear with everyone, is basically that when this one, okay, the battery pack design, okay, this definitely also has a lot of value on the approach that you're using. Okay, and then when we are having the 101, this will also carry a lot of value on the approach that you're using. Okay, your understanding, all those things will be also tested, like how you have done. Okay. So I'm not able to turn mic. Okay, so okay, so okay. And port most probably configuration. Uh, okay, I think Prasad, if you're not able to turn your mic, I would say just put the query. Okay, if you have. Meanwhile, let me take a note of it. Basically, two things. We will put it tomorrow morning. That is the drive cycle. Okay, tomorrow morning or by tomorrow afternoon. Okay, and then the other is that we'll also add the estimated parameters of the cell. Okay, okay, in case if you want to try a battery backup.
Um, yeah. So I
Okay, who is this? Rhythm. Okay, yeah. Okay.
yourself if it's possible right now.
Sorry, Rhythm, you're saying something. Yeah.
Yeah. Sorry to cut you. Uh, yeah. Actually, I have unmuted Prashad. He can able to unmute himself.
Yeah, Prasad, can you unmute yourself? See if you can unmute on the right side top. You must be having the mic, right? And then you can unmute or yourself and you can speak. Okay, so you're saying, okay, meanwhile, since I mean, I see your question, uh, that you made a battery pack, made its library, but when I open it, the capacity of battery is not correct. So when you're opening it, see if you're not seeing that, then you can go and change, right? Okay, the library that has been created, you can go and change that, yeah, manually. You can do that. Okay, sorry. Okay, I misunderstood your question. Okay, so basically the output of the capacity, the parameters. Okay, you're not able to edit the parameters. Okay, this you can send me. You can send me to the racing launch at MathWorks. Send me that actually. Put the images and all that you have. Okay, add a images like what is the issue, because this is more product specific, so we can answer. Not a problem. Okay. Okay. Uh, any other question? Anyone? I'll just wait for 1 minute. It's 8 o'clock now. I'll wait for 1 minute and you can tell me if you have any further questions. Okay. And meanwhile, you can also as I mentioned at racinglaunch@mathworks.com, just put the query and I'll send you the document, those who haven't got it, and even the slides as well. I'll send you. The format of the powertrain is necessary to be as same as the model which you show now. I mean, see, when I didn't get that question exactly, when you say format, so basically what we want is that you want to change it as per your vehicle parameters. Now, after this, you can have, like, if you have a differential in place, you want to, like, this is a place where you can, and a lot of people are having differentials, right? You can add a differential over here. Okay, that can be definitely, I mean, you can change that. Yeah. And also, like, as I mentioned, those who are having the motor parameters, they can do it, but I mean, make sure that you're able to do it. It's not that easy. Okay, because again, you have to modify and change the controllers as well. And yeah, I mean, as I said, that it is not going to be easy. It is definitely you have to little bit I would say use your would say understanding of the system to make things work and excel, I would say, in this challenge. Yeah. Uh, a result how to check? I think I would say that when you have the models ready, okay. See, this is the model. Okay, in the visualization, you can go and see the velocity comparison, the SOC. Our range is quite simple, but focus on the state of charge. Okay, you go into that. Okay, then you can also get into electric powertrain. If you want to, there are multiple sensors as well, but the, see, let me, visualization will give you velocity comparison and SOC. Okay, and then if you want to add some sensors, there are multiple sensors like here that if you want to, I was talking about the voltage sensor, if you want to measure it separately or kind of try to debug some things at certain step, that also can be done. Voltage sensor is there. Okay, then you have, I think, I'm forgetting the name, but anyways, it is in the library. So you have Simscape in the foundation library. You have, let's take anything, mechanical sensors. You can see over here, ideal rotational motion sensor, torque sensor, everything else is there. Okay. So I think mostly you were asking the results. So I just showed you in the visualization, you can find those results. Yes. Okay. Any further questions? See, I would say the question basically, if you are submitting the completely open model, definitely it won't be eligible. Okay. At least the structure that we have given, because it will be unfair with all the other people. Okay. So that's why we have given a template model. In that, the task which we have given, that you need to kind of like do that. Now in that, if you have like in the powertrain, for example, H bridge you are adding, PWM controller you are adding. Okay. If that you are adding the H bridge and even what you said, if you have a powertrain that you have modified, you can add that and submit that. I hope Rohit it was clear, and let me know if you have any question. Okay. Okay. Anyone else? Any other question? So as an action item, two things that we will do. We'll add the drive cycle, okay, on which we will test. Okay. We have multiple, but we'll give you one sample. Okay. And then we'll also add the estimated parameter of the cells, like so that if you want to kind of try that and build the battery pack based on that, okay, you can do that. Okay, cool. I think we were able to answer most of the question and the queries. So yeah, I would say all the best to everyone. As I mentioned, send your question on the racinglawn@mathworks.com. You don't have the document, you don't have the slide, you want the slides and also resources, and at the same time, if there's some issue with the product that you're getting issue, just reach out to that email ID. Okay, yeah. Okay, awesome. So yeah, Rhythm, I think we can close the session now. And thank you all
Yeah,
again for joining.
yeah. Thank you, sir. Thank you so much for delivering this wonderful session and yeah, so solving all the queries which students are having. Hope the students have gained lot of experience from this and will definitely put it into their learnings. Uh, yeah. Thank you, sir.
Yeah, thank you. Thank you, everyone. Thank you so much. Thank you.